would take place starting in different ways in these different reactor geometries and try to refine them. Now here, hypothetically, it says this is going to take you 6 hours. I say I'm impatient, I'm giving a speech. So I'm going to say, hey, what got any of that cloud capability out there? And so I might be part of a consortium of universities, or the National Science Foundation may provide some of these assets. But I can essentially, add a few more computers to this. Maybe drop it to an hour, or maybe I get a really big cloud and I drop it to 11 seconds. Very convenient for a talk like this. In reality, I think this is the kind of thing that we will do more and more, and that as you're able to compute many of these things and then evaluate them across a very large parameter space, you might in fact come up with one that looks like it meets your goals, and it may be counterintuitive. So this is actually a real output of a run that John's people have done, and it is one real configuration. So here is sort of a three-dimensional model that is sort of looking down at a cutaway view of the reactor core for one geometry. And I can take this control and I can essentially start to slide it along from the 0 to 45-year simulation. And I can look at the different parameters and how they unfold in the course of the time where this reactor burns through the fuel. And they are investing all kinds of different ways to do this. Where the geometry dictates, well, do you light it in the middle and burn out? Do you start at the outside and burn in? Do you run it along a cylinder? Nobody really knows what the right way to do it is, but we know that the traveling wave concept looks extremely promising. And so the ability to have other people take this and add their own intuitions, or add more experiment, or add more computing capability, I think are all indicative of the way that we're going to have to come together to solve some of these super hard problems. So let's say I've done today enough on nuclear, but I'm a zero carbon guy, so I want to look at wind. And so I'll say, load my recent wind farm research. So here I might be in the business of trying to optimize the power production from a wind turbine. So I load up from the internet the terrain maps. I can put the topography on top of it, and I can put in models of the wind farm as we have historically put it in. And we can now, I think, easily assume that all of these things are instrumented with a lot of sensing capability and the ability to record things over long periods of time. So this gives me live data that I can start to try to play against these models if I wanted to optimize what the wind farm would look like. And so here we can see vectors that indicate, look, the terrain really does affect how the wind flows around these things, and are there things that we could or should be doing? Some people are actually looking now at the idea that you can actually have the blades of a wind turbine that actually alter their aerodynamic shape dynamically as a function of wind velocity and other parameters. And so there are many complex questions around this. So let's say load my flow models. And so here I've been working with some people on a variety of different aerodynamic flow models. And I want to use these things to study one of these and see if we could make it any better. So here I'm going to tap one of these to say I'm going to use it as a proxy for the others, and kind of simulate what I think the work environment of the future will actually be like, where your desk is actually a sort of control and touch surface, and you'll have many different types of displays available. Here this piece of plexiglass has been specially treated, and it allows me to essentially project images on it, and even though I can see through it, I can also see images that are placed there. I think of this as a proxy for probably a three-dimensional display that will be available in the next few years, where I could really look at this model in a stereoscopic, three-dimensional way. And so just as people today go to the movies and are starting to see movies in 3D, I think increasingly scientists and engineers will find that that could be a common practice too. So I'll take my pen and just sort of flick this model up onto the screen. And here I want to use gestures as a way to sort of give me a natural way of interacting with this three-dimensional model. So here we expect cameras, like the Natal camera, will be used to do these kind of projections. And so I'll use my hands and basically say I want to tilt this thing back a little bit so that it's upright. I can essentially zoom in on it and stretch it out and look at the wing and see what the airflow over the wing is. And so the model allows me to change parameters in a couple of ways. So in this way I might actually just circle it and say I want to change the pitch angle from 4.1 to say 10 degrees. And that'll change the model and tilt the wing differently. It shows there's sort of a visual control on there, that blue thing. Here I've improved a little bit, but it isn't quite what I want. And so the next thing I'll do is say, it's very hard for me to describe in parametric terms what I think optimal laminar flow over this blade might be, but visually, I might be able to determine that, or at least have some pretty good intuition about it. So I'll basically use gestures to essentially grab a hold of the control in this environment and essentially sort of start to change some of the parameters of the blade. And clearly that got worse. So I'll basically push it back down a little bit until I start to get the thing to be mostly green, and I'll say, okay, that looks like the best I've got today. So at this point, you're given natural ways of interacting in this three-dimensional world. And so I can say, all right, let's take that and assume that that's the way we're going to do wind power on this thing today. So I'm going to take that and I'll sort of drag it back down into the model, and that'll apply it uniformly to all of the different things, and I can replay this simulation and determine whether in fact I got the kind of power output that I really wanted. This whole question of natural user interface and gestures and things is actually not as far in the future as you might think. One of the things I meant to show earlier and I didn't, but I'll run it now, is in May of this year we introduced a new capability which is a camera that allows computers to essentially see depth. Most video cameras just flatten things out into a plane. And if you're really trying to do things like these kind of gestures, it's very hard to make that work. And yeah, we believe that being able to couple yourself into computer simulations of various forms would be important. In the first place, we decided to bring that forward will be in the gaming environment. So we announced a project called Natal in May at the game show, and demonstrated this to people to get an idea of what it would be like when people, in the gaming sense, where you are the controller. And so we took a video, which I think the team can probably still play for me here. And this is kind of the reaction.
Are you guys familiar with Project Natal?
Yeah, he was just talking. We're just talking about it.
Do you guys want to come up and demo it?
Yeah.
All right, do it.
Oh, there's a lot of them! It is literally the future, this thing. The idea that you are playing a game with no controllers, with no touchpad, with nothing attached to your body, and it recognizes everything you're doing, it was insane. It's going to change gaming forever, for sure.
Actually really gets your adrenaline going a lot.
Move your off and drag it just like that.
Oh, guys. Holy crap, this is awesome.
More than just like holds onto that controller.
This is fun.
Oh my god, he's closing it.
Ow!
It's amazing. It's like so cool. I can't wait to like throw a fireball like that.
I'm exhausted. But it was so much fun. I'm actually really surprised that I could do that.
This is by far the most energetic video game I've ever played.
If you could do like laser tag in your house, and you could put obstacles all around your living room and then use them inside the game. And if I wanted to shoot, I could just go like goose, 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 goose. That's the game that I don't know if you would call that game, but I would call it awesome.
So when we give the beginnings of this world of the natural user interface to people, even in this environment, they get very enthused. When you think about it, gaming is an example of a place